All right, welcome to Chapter 10, Section 3, called Special Right Triangles. This is for Integrated Math 2, or IM2. So a couple things you'll see on your screen here before we get started. The first thing will be a due date. You don't see that on my teacher preview here, but you'll see it on your student screen. The second thing is unlimited attempts. You always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is best score, so whichever one is the best one is the one you keep. Partial credit is enabled. So if you answer one of two questions correctly, you get credit for the one question or however many you answered correctly. And then down here it says, please remember once you start your homework, you must finish it before you can work on anything else. That means once I click the start button, down in the bottom right corner, I will see a submit assignment button. And I'm going to make sure to click that button to finish my assignment. That's what it means, is I've clicked that button. So it does two major things when I click submit assignment. Number one, that first screen said I can't work on anything else until I've finished. So what Alex is going to do, if you don't click submit assignment, if you just close this screen when you want to leave, or if you just close your computer, it's going to leave this attempt open. And by not letting you work on any other assignment, it means it's going to freeze your account. You can't work on any other assignments. You can't look at resources. The gradebook's not going to change to a certain degree. So a whole lot of things get frozen until you click submit assignment. Remember, you don't need to leave the attempt open, as Alex is trying to do for you, because it's going to save your place and you have unlimited attempts. So just click that button, to make sure you don't get locked out of everything. And like I said, the second big thing is the gradebook. It updates the gradebook when you click submit assignment, so your teacher can actually see what you've been working on. Up until that point, your account's kind of just frozen on that assignment. So just two big reasons. Always get in a good habit of clicking that button. On the side here, we always have explanation, example, and message center. Sometimes we have the calculator open. So explanation tells me I'm going to lose my question attempt because it's going to give me the answer to this question. So it's not going to give you the answer and then let you come type it in. Example, though, will give you a very specific example for what we're doing. So special right triangles specifically have to do with what we call a 30, 60, 90 triangle. So we have a 30, 60, 90 triangle, and we also have a 45, 45, 90 triangle. So these are our two right triangles. I'm going to try to draw this kind of nicely here. So we have, I'll go same direction as them, 30, 60, and 90. And then we have a 45, 45, 90, which is also, it's a right triangle that is isosceles. So that's another piece that we want to remember, because since the two base angles are the same, the opposite angle or sides are also the same. And when we have these special triangles, we have this very specific relationship between the two. So on a 30, 60, 90, if we have the smaller side across from 30 equaling x, or whatever number it is, then the hypotenuse, which is across from the 90, the longest side will be 2 times the small side, and the line, the segment that's across from the 60 will be x times square 3, like that. So this is a very specific relationship that comes up here. On a 45, 45, 90, if we have the sides equaling x, then the hypotenuse, again, across from the 90, is going to be x times the square root of 2, like that. So using this relationship, we can kind of go around the triangle and figure out any of the missing pieces. So once we know that, we can go through and we can look at their examples, see how they're working it out. They do actually want the decimal forms of numbers here. It says round to the nearest 10th right here, so we know we're going to be doing some rounding. And then you can also message your teacher directly from this screen so that they know where to come help you, because it attaches a picture. Very nice. All right, so now that we know about 30, 60, 90, and 45, 45, 90, we can go ahead and start working on these pieces. And the main thing with this one is it's a right triangle. If we had at least 2 of the pieces, we could definitely use Pythagorean theorem. We don't have 2 of the pieces, though. With this one, we could actually figure it out a little bit easier because it's going to be a and a as far as the length. So I'd have a squared plus a squared equals 5 squared because of Pythagorean theorem. But using these special right triangles, I don't have to use Pythagorean theorem. I can just go, okay, well, this is 45, 45, 90, so I'm going to look here. And if I have x square root of 2, this equals 5, to go from, and I'm going to erase that, to go from here to here, I'm dividing by square root 2 to go this direction, because the square root 2 goes away. That means I'm dividing by square root 2. If I'm going this direction, I'm multiplying by square root of 2. So I just need to look at which direction am I going. kind of a thing. So since I'm going from 5 to the A, I'm going from the hypotenuse to the side. I'm going to do 5 divided by square root 2. I can't leave it like this. If we put it into a calculator, this actually will just divide it for us, divided by square root 2, and we can just round it off. If it wasn't asking me to round to the nearest tenth, though, I would need to rationalize it and move the square root 2 to the top by multiplying the top and the bottom by square root 2. So you'd have to rationalize it. Since it's a decimal, we don't need to go through that step. I can just go here and say, okay, well, I'm rounding to a tenth, which is the 5. That's 1/10, or 5/10. I need to make sure that the hundredth, the next number, is not 5 or bigger. And it's not, so it's just going to drop down. It's just going to be 3.5, like that. So now, if we're looking at the next one here, we have our 30, 60, 90. And so I have my hypotenuse is 2, and they want the side across from the 30. That's the short side. So if I'm going this direction, I'm going from 2x to x, so I'm dividing by 2. If I were going from the short side to the long side, I would multiply by 2. So again, just which direction am I going? I'm going this direction, so I'm going to divide by 2. So 2 divided by 2 is 1. All right, we're going to check that. Keep moving. Next. So the next one, we're still going to work with some special right triangles here. We're just doing the same exact idea. So we just need to decide which direction are we going and how do we get there. So, shh. Sorry, my dogs are in the background here. So we have our triangles below. So we're starting with 30, 60, 90. And we're going on here. So we're starting with the hypotenuse, and we want this one over here. So we have to kind of work our way around, because I need to get to x. I need to divide by 2 to get to x, and then I need to multiply that by square root 3. And it says write your answer in simplified radical form. So it wants exact answers. It doesn't want our decimal rounded anymore. So we're going to take 8 and we're going to divide by 2. That'll bring us down here to 4. So the length of this one is 4. And then 4 times root 3 is just 4 root 3. There's not anything we can do about that. We just leave it 4 root 3. All right, for D, it wouldn't matter which leg I'm looking for. If I'm looking for the bottom one or if I'm looking for the side one here. Either way, I'm going to divide by root 2, like that. Or if I was going this way, I'd be multiplying. So the 45, 45, 90 doesn't matter which direction you're going. You do the exact same thing. You're either going to be dividing by root 2 or multiplying by root 2. So with this one, I'm going to take 6 and I'm going to divide by root 2. Because it wants it in radical form, this is what I was talking about in the last one, we can't leave it like this. This is not the correct simplified radical form. I need to take this root 2 and I need to basically move it to the top. And to do that, I'm going to multiply by the same thing on top and bottom. And so this is going to become 6 root 2. And on the bottom, if I have 2 times 2 for my roots, I can literally put them together like this. That's one of the properties of square roots, or square root multiplication. So when I'm taking a square root, I'm saying what number was multiplied by itself to get the answer, to get the square. Well, if I'm doing 2 times 2, 2 is being multiplied by itself. So when I'm multiplying a square root by itself, it just comes out of the square root sign. It is the answer. It is the square root, because I'd have 4 here. Well, the square root of 4 is 2. And then I need to make sure that I reduce this, because 6 can divide by 2 3 times. So we end up with 3 root 2 for this one. All right, so that was section 3. I will see you in section 4.